Okay, so what we will be working on today is just graphing polynomial functions, okay, without a calculator. So you're probably wondering, well, how am I going to know where, because a polynomial function, the graph of a polynomial function, hopefully you realize it could have lots of curves, real high, real low. The thing is that I'm not going to be concerned about how high or how low it goes. All I want is the intercepts, the x-intercepts, the y-intercepts, and I want to know the general shape of the graph. So that's what we're going to work on here, okay? So find the general shape without using technology. Okay, you have to show what's called the end behaviors, what's happening far off to the right and far off to the left of the function. And you have to show all the intercepts with what's called proper multiplicity. Okay? So, what we're saying here is that we're going to look at the factor of a function. Okay? Now, we're also going to look at the degree of the factor. So let's back up here. So let's say that we've got this function right here. So there's a factor, and there's a factor. Okay, so we've discussed this, so this is just a review, that we know that if these are the factors, then this is a solution, x equals 2, and x equals -4 as a solution. So we know that it's going to cross, this function is going to cross at -4, it's going to cross at +2. Okay, we know that. So if you have a factor, then you know that you're going to have a solution at C0. Okay? Now, the question is what happens when the function has not just a degree 1 here? What if it has a degree, what if it's 2 or 3 or whatever? Okay? So let's kind of explore that. Go ahead and take out your iPad if you want to do a little exploring. Okay, so let's go y equals x minus 1. So we can see that it crosses at 1. Now this is not a curve. Let's put in another factor so it is a curve. Let's go x plus 2. So it has a intercept at 1, 0 and 2, 0. Okay, -2 is an intercept and 1 is an intercept. Okay, but the question is, what happens when we take this to a power? So let's take this to a power. Put a 2 there. So at 1, what did the function do? It didn't cross. It was tangent. What did it do at 2? It crossed. Okay, so let's add a power other than 1 there. So this is a power of 1 right now. Right? So that wouldn't change at all. That's a power of 1. Let's change that power to 3. So at a power of 3, it crosses, but it kind of flattens out a little bit. Okay, so what we're going to talk about is if you have a function that has an intercept that has an even power, that has a multiplicity of 2. So the exponent is the multiplicity. If the multiplicity is even, then the function is tangent at that value. If the multiplicity is odd, then it is going to cross at that value, whether that is a multiplicity that's out of 1 or of 3, it still crosses at this value here, even of 5. Okay? So let's go back and let's write that down. So if k, the power, is odd, then the graph crosses the x-axis at C0. If it is even, then the graph is tangent to the x-axis at C0. So that's what you're going to have to graph when you graph your functions. So polynomial functions, we've talked about this. Y equals a to the n x to the n, actually a sub n, sorry about that. A sub n just means it's a constant. This actually is an exponent. So that's the leading term right here. That's your degree and the coefficient out in front. It helps determine something about the function. So you might have a function that's even. Again, it's even if this leading term, the stuff out in front, is an even number. Okay, so it might be even, it might be even, it might be odd. And then we're going to look at what happens if the leading coefficient is positive. What happens if the leading coefficient is negative? What happens if it's positive in this case? Or negative here. Okay? So the n behaviors is what happens way off to the right and way off to the left. When x is big negative or when x is big positive, what does the n behavior, what does the graph look like, the arrows? Okay? So like the n behavior here is down on the left and down on the right. Well, let's go back. I'm going to go back. Let's see if we can play around with our function here a little bit. So let's make this just a 1. So the degree of this function would be 3, because this would be an x squared times an x would be an x to the third. Now the leading coefficient really is going to be 1. So there's kind of 1's hiding out in front of that, so that's not really any different from before than it is now. So the leading coefficient is 1 and the degree is odd. Well, let's do this. Let's change this leading coefficient, and again, let's ignore that one here. Okay, so let's change this coefficient to a negative so it reflects it. So no matter what that leading coefficient is, if it's negative, the n behavior is up on the left, down on the right. Or up on the right, down on the left when it's odd. So we were talking about an odd function. If a is positive, if this is positive, it's up on the right, down on the left. If it's negative, it's up on the left, down on the right. You have to memorize that. Now the easiest odd function is a linear function. And another name for that linear function's leading coefficient is the slope. So if the slope is positive, doesn't it go like this? If that leading coefficient is positive, a sub n, or m, if you want to look at it as m, it's going up to the right. Here it's going down to the right. If you have a slope that would be negative. Okay? So thinking of the simplest even function. So the simplest even function would be this. So if the leading coefficient is positive and it's even, what's our n behaviors? Well, I think we know that it's going to go up on the right and up on the left, and it's going to have one bend in the middle. If we were to change that to a negative, it would be down on the left and down on the right, and that's what happens on all even functions. Those are your n behaviors. You need to memorize them. So let's graph them. So the problem with these two here is that we don't know the x-intercepts. So we're going to have to factor this to find the x-intercept. So this one has the greatest common factor of not only 2, but x squared. On the right side of the plus, there would be a factor of 2 left, and on the left side, there would be a factor of x. So this would be 2x cubed, and that would be 4x squared if you redistributed it. So that's going to help us find the x-intercepts. So I already wrote on here that the leading coefficient is positive. Okay, the highest degrees term, or the number out in front here of all the factors. Right, here's all the factors. That's your leading coefficient as well, is that. And it's an odd function. 3 an x squared times an x. So you should be able to figure out what the degree is by looking at it in factored form too. So the x-intercepts are -2 makes that function 0, that factor 0, and 0 makes that 0. What's the multiplicity of -2? Well, there's a 1 there, so it's a multiplicity of 1. It's just that degree. And the multiplicity of the x is 2, because it's a squared. So this tells us that it's positive and an odd, so our end behaviors are going to look like that. So let's graph it. So 0 and -2. That's the only place that our function can cross the x-axis. If it crosses anywhere else, you draw a graph that crosses anywhere else, it's wrong. It's going to be tangent at 0, and it's going to go through at -2. Even, tangent, odd multiplicity goes through. And it has to end up like this. Okay, so let's say we're starting from the left. Okay, so we hit -2 and we're going to have to go through. I don't care how high or how steep you go, it doesn't really matter. Then at 0, we have to be tangent, so that should make sense. If we're tangent here and finish up there, that would give us a pretty good graph of what's going on. Now, what is the y-intercept? The y-intercept also is 0. Okay? Let's look at this one. Let's factor out a -1x squared. So you have an x squared left in this term. And if you divide out a negative, you'd need a negative times a negative to equal that positive. So it's going to be a -4x. And then you have +3. So that's your function. Not quite in factored form yet. So let's factor this quadratic. X and x, front and front. Last term and the last term have to multiply together to be 3. 3 and 1, and they have to add together in the middle to be -4. So, what's the degree? Well, the degree is 4, and it would be 2, another factor here, so it would be an x squared times an x squared. That'd be an x to the 4th. In factored form, you should be able to tell that. So the leading coefficient is negative. The degree is 4, even. So what are the end behaviors? I think it's going to be down on the left and down on the right. Even, just like a parabola that has a -a. X-intercepts are 0, 3, and 1. Multiplicity of 2, it's going to be tangent at 0, and it's going to go through at 3 and through at 1. Now you graph it. See if you can graph it. So at 0, it's going to touch 0, and it's going to be tangent at 0. Come back down. At 1, it's going to go through, and 3, it's going to go through. So we're going to bounce back up here and go through, and then we're good. Okay, let's look at one more. Now this one's already factored. Leading coefficient is negative. Degree is, there's an x squared times an x to the 3rd, to be x to the 5th, times an x to the 6th. So you could count the exponents to find the degree. 2, 3, 4, 5, 6. So the degree is 6. It's even. So an even negative, same as last time. So the x-intercepts are 2, -4, 0, multiplicity of 2, 3, 1. Graph it. So at -4, it's going to go through. At 0, it's going to go through. Now, the only way for it to touch this and to finish down here is for it to be tangent, which it is. Okay, so good enough? Good luck.